This is a basic example of how you might structure a program to send message and receive message using RA01 v3.2 LoRa module with Nodemcu ESP8266. However, please keep in mind that you might need to make adjustment to the pin definitions and frequency settings and any other specific details based on your module and configuration. And ensure that you have connected the correct pins between the LoRa RA01V 3.2 module and Nodemcu ESP8266 and that you have provided the appropriate power supply for RA01 module. And always refer to the data sheets if you want and specifications of your components for accurate and up-to-date information. This bidirectional communication of LoRa WAN with ESP8266, this experiment video I have already done and uploaded. So you can refer that video for doing experiment. The first instruction is hash include string.h. This line includes standard C library, a header file string.h. This header file provides various functions for working with the string in C and C++ programming languages. And it is likely that the code might use string manipulation functions from this library. The next code is next line is hash include LoRa.h. This function, LoRa header files. These three lines are used to define the pins, SS pin, RST pin, and DI O0 pin. Next is string data. So this line declares a variable named data of type string. The string type in Arduino programming, it is used to store and manipulate a sequence of characters. What is sequence of character? It is string only. In this case, the variable is initialized as an empty string. Here I have not defined anything. It is an empty string. Next, Boolean string complete is equal to false. So this line declares the Boolean variable named string complete. The variable name is string complete and it is initialized with the value false. This variable is used as a flag to indicate whether the complete string of data has been received or not. So it will be used to track the status of data reception. Next is character input data. So this line declares a variable named input data. The variable name is input data and it is of type character. This variable is used to store individual characters of incoming data. So it will be used to build up the complete string that is being received. So as data is received, that the individual characters are read one by one and it is stored in the input data variable. Next is string reading ID. This line declares another string variable named reading ID. This variable is intended to hold some sort of identification or an identifier. So it is used to store the ID associated with the data that is being received. Okay. Then string status. This line declares another string of variable name status. So this variable is intended to hold some status information. So this status information could be related to the state of program, or it may be the device, or it could be indicate the result of some operation. So the string complete flag is set to true. This flag is set to true. String complete flag, the upper one, it is set to true once complete string has been received. And this flag can then be used to trigger actions and that should occur when complete string is available. Okay, next, wide setup function. So this is a special function in Arduino programming, and it is called only once when the microcontroller is powered up. Next is serial.begin 115200. This line initializes the serial communication at a baud rate of 115200. Serial communication is a way to send data and receive data between Nodemcu and LoRaWAN device. So by calling serial.begin, you are configuring Nodemcu to communicate with other device using a specified baud rate. Next, pin mode D4 comma output. This line sets the pin label D4 as an output pin. This line sets the voltage level of pin label D4 to high. 1 means high. Similar to the previous two lines, the pin mode and digital write, these lines, D3 comma output, D3 comma 1, D1 comma output, D1 comma 1, all the 4 lines set and configure the pin labeled D3 and D1 as output pin and set its voltage level to high. Okay. Next, while serial. So this line creates a loop that continuously executing until the serial communication is established. In other words, I can say it waits until the serial communication between Nodemcu and the LoRaWAN becomes active. And this is often used to ensure the program does not proceed until the serial communication is ready. Next, serial.println device activated. So once the serial communication is established, this line sends the string device activated to the connected device through the serial port. So this is useful for providing status message or debugging information to the user or a developer. Next, scroll down. Next is this line. LoRa set pins. Okay, this line. LoRa set pins SSRT DI0. This line configures the pin for LoRa module using set pin functions. So we can configure with the help of the function set pin. The values SS, RST, and DIO0 are likely previously defined constants. Just now I explained. It represents the specific pin numbers on the Nodemcu board. So these pins are used to control and communicate with LoRa module. Next is this. So I'll tell you what is SS. SS is a slave select. Here SS. SS is slave select. It is often used in serial peripheral interface communication. So when you set SS pin low for a particular device, the device becomes active and others are inactive. In LoRa module, the SS pin is used to enable communication with LoRa transceiver, essentially signaling the device is ready to send or receive the data. Next is RST. RST stands for reset. So it is used to perform reset operation on the device. In LoRa module, RST pin is connected to microcontroller GPIO pin. So it allows the microcontroller to perform reset of the LoRa module if needed. Next, DI. D stands for digital. IO, input output 0. DIO 0. So it stands for digital input output 0 and it is used as general purpose digital pin. So in LoRa module, DIO 0 is often used as an interrupt pin. Okay. Next. Next line is if not LoRa begin 433 E6. So this complete I'll explain. If not LoRa begin 433 E6 serial dot println LoRa error delay 100 while 1. So what are all these 4 lines, what it indicates? So this section, sorry. Okay, these 4 lines. This section attempts to initialize the LoRa module for communication on a specific frequency. So 433 E6 represents 433 megahertz. E stands for mega. E6 represents megahertz. 433 megahertz. If the initialization is unsuccessful, the code prints LoRa error. So it will be printed on the serial port. And after that, it introduces this one. It introduces a delay of 100 milliseconds. And again, it enters into the while loop and it halts the program. So this can be used as an error handling mechanism, indicating that LoRa module failed to initialize properly. So after that, we have a function data.reserve 200. This line reserves a memory for a data variable. Okay, so the data variable is a string type. It is used to store incoming data. So we are reserving a memory here. And the space, allocating space for up to 200 characters within the data variable. Okay, so till now what I explained, this part, it sets up the environment for the Arduino sketch to communicate with the LoRa module. It waits for the serial communication to be established and it initializes the LoRa module and it provides the status message and it prepares the data variable for potential incoming data. The error handling mechanism is in place to handle cases where LoRa module initialization fails. So up to this much explanation over. Next we have while loop. So under that, the first one is string A. So this line declares a string variable named A. The variable is declared with the scope of loop function. Next is serial event, this one. So this line called serial event function. The serial event function is a special function. It is provided by Nodemcu framework and it is called whenever serial data is available to the read. Okay, so it is usually implemented by the user to handle incoming data. So it is used to handle the incoming data. Next, string complete is equal to false. This line sets the string complete flag to false. It appears that this flag is used to indicate whether the string of data has been received. By setting it to false at the beginning of the loop, the program is prepared to detect and handle new incoming data. Next is int packet size LoRa dot parse packet. So this line uses a LoRa dot parse packet function to check if there is a packet of data available to read from LoRa buffer. Okay, so the function returns the size of the packet in a bytes. That's it. It returns the size of the packet. Okay. Next, if size packet. This one, if size packet, while LoRa available, print message received. So if size packet, this line checks if packet size has a value greater than 0 or not. The packet size is set by LoRa function. And non-zero value indicates there is an available packet of data in the LoRa module. While LoRa available, this line starts a loop that runs while there is a data available to the read from the LoRa module. The condition LoRa dot available checks if there is a data ready to be read. Okay. Next, serial dot print message received. This line prints a message to the serial monitor indicating that the message has been received. Next, string LoRa is equal to LoRa dots read string. So this line reads the incoming data from LoRa module using LoRa dot string read string function. It reads the entire available data as a string and it stores it in a LoRa data variable. Okay. Serial dot print LoRa data. So this line prints the received LoRa data string to the serial monitor. It displays the complete received message. Next, serial.println LoRa data dot chart 0. So this line assigns the first character of the received LoRa data string to the input variable. So all these things are used to print some data in a serial communication. And next line is if input is equal to 1, string println getting data 1, digital write D3, 0, else if input data equal to T2, print getting data 2, digital write D1, 0, else if, so these conditions I'll explain. So this part of the code checks if the input data is equal to the character 1. If this condition is true, the code inside the curly braces will execute and it prints getting data 1 to the serial monitor. And it sets the digital pin connected D3 to 0. This one. Else, the next part of the loop. If the first condition was false, if this condition is false, it will check for the second condition. This part checks if the input data is equal to character 2. If it is true, it prints getting data 2. And it prints, it sets the digital pin connected D1 to 0, turning off. Else if it checks the condition equal to 3, then what it prints, if neither the previous condition was true, this part checks if the input data is equal to 3. If true, it enters loop and that runs 10 times. This will run 10 times. Okay, because I have written for loop here. This loop will enter loop that runs 10 times. And inside the loop, it prints getting data 2 to the serial monitor. And it sets the digital pin connected D1 to low. And it introduces 200 milliseconds time delay. And it sets the digital pin D1 to high. And it turns it on. Again, it introduces 200 milliseconds time delay. Last one is else part. So if all the conditions are false, then what it prints, if none of the previous conditions were true, this part acts as a catch-all. So what it does, it prints getting off data to the serial monitor. It sets the digital pin connected D3 to high. It sets the digital pin connected D1 to high. Like this, both D3 and D1 becomes high. Okay. So the next function is last. This is the last function, serial event function. So serial event function, it is a special function provided by the Arduino and it automatically called whenever there is incoming serial data available. So this is usually useful for handling incoming serial data, handling asynchronous data. It is used to handle the asynchronous data. And inside the loop, you have character serial dot read. So this reads a single character from serial buffer and stores it in char. That is the variable name. Next, data is equal to plus equal to in char. So it appends the incoming characters to the data variable. And next, one more if condition. If in char is equal to slash n, it checks if the incoming character is a new line. If new line character often indicates the end of the complete string or a message. So if new line character is detected, again the following action takes place. String complete is equal to true. So this sets the string complete flag to true. It indicates that complete string of data has been received. And it prints the message sending message, this one, and followed by the complete data string to the serial monitor. And the LoRa module is prepared to send data. LoRa.begin.packet. Okay. So this begins the process of sending packet of data via LoRa. Next, LoRa.print.data, this one. And it sends the complete data string via LoRa. It completely sends the data using a LoRa. Then last, LoRa.endPacket. It can be used to control the external device. After that, it will introduce a 200 milliseconds of time delay. Then D4 pin is set back to high. D4 pin is set to 0 after 200,000 milliseconds or 2 seconds. The D4 pin is set back to high. So finally, the serial event function, it reads the incoming characters from the serial buffer, appends them to the data variable, process the data. When the complete message is received, and then the complete message is processed and it sends via the LoRa module, and some control digital signal are managed accordingly. And this function essentially handles the reception and the transmission of data over both the serial and the LoRa interface. So this is the complete explanation of LoRa interfacing of LoRa with Nodemcu. So for this experiment, we need 2 LoRa module and 2 ESP8266 Nodemcu modules. So the two-way communication we can do. Each LoRa module acts as a trans receiver. We can send and receive the data. And for this, we need 2 laptops. One LoRa module and ESP is connected to one laptop, and another LoRa module and ESP8266 is connected to another laptop. So how to do the experiment and how to check the communication is taking place or not, that I have explained in the next video.